This is a problem that I've been assigned. You can go ahead and pause to read the whole problem. In summary, this problem says that radiation from the head is a major source of heat loss from the human body, and then it asks us to model the head as a cylinder that's 20 centimeters tall and has a 20 centimeter diameter, and it asks us to find what the net rate of heat loss is. An equation that we should already be familiar with that can give us the rate at which an object radiates heat energy is this equation. If you've never seen this equation before, I recommend going back to section 19.8 of our textbook where it introduced it and talked more about it. So, to use this equation, we need to have what E is. We were already given what the emissivity of the surface is in the problem. Here we were told to use 0.95. Next, we would need this, which is the Stefan-Boltzmann constant, and we already know that that is equal to 5.67 times 10 to negative 8 watts per meter times kelvins to the fourth. Then we would also need the surface area, which we weren't given the surface area, but we were told that to use to model the head as a cylinder, and we know to find the surface area of a cylinder, we can use this equation. To use equation, you need radius and you need height. We can get the radius because we were given diameter, and then we were given the height. Then we also need a final temperature and an initial temperature, and for this problem we're going to use the initial temperature, which is the smaller temperature as what the temperature is outside, and we're going to use the final temperature as the temperature of the head. But to use this equation, the temperature needs to be in Kelvin, so we can add 273 degrees Celsius and get that T initial is 278 kelvins, and then do the same thing for the other temperature, and we're going to get that it is 308 kelvins. So now we have everything that we need to solve this problem, and we just need to begin by finding what the surface area is, because that's the only value that we were missing to use this equation. So surface area is going to be, from this equation, is going to be 2 pi times the radius, which is 1 meter, times the height, which was 0.2 meters, plus 2 pi times the radius squared, and so we're going to get that the surface area is equal to 0.17 meters squared. And now we have all the values that we need to use this equation. So the rate at which the head radiates heat energy is going to be the emissivity, which is 0.95 times Boltzmann constant, which is 5.67 times 10 to negative 8, times the surface area, which we found was 0.17, times the final temperature to the fourth, which is going to be 308 to the fourth, minus the initial temperature to the fourth, which is 278 to the fourth. And that is going to give us that the rate at which the head emits energy is going to be 25.1 watts.